So this is the back side of that page of notes that I printed out for you. And on the back side, on the front side, we were talking about domain and range, which we definitely need to know. We've been practicing domain and range. But on this back side, we're now actually going to start graphing and dealing with piecewise functions. A piecewise function is, or better said, are pieces of more than one function together on one graph. So this is the way it looks like. This one's called f of x. Now it might be called g of x or h of x or whatever you want to call it. In this case, it's f of x, and it has two pieces. Check it out, guys. We have this first piece. I'm going to highlight it in red, and I'm just going to rewrite it right here on the side. Instead of f of x equals, I'm going to write y equals negative 3x minus 4. Now you might want to write that down as well. Now I do advise this. If you don't have a pencil, you probably don't want to graph right now, okay? If you do have a pencil with an eraser, you definitely want to graph. Again, if you have a pencil, we're going to be erasing. Make sure you have a pencil with an eraser. If you have a pen, you probably want to wait till you have the finished product, and then you could follow along. So let's focus in on this equation, y equals negative 3x minus 4. That's y equals mx plus b. That's semester 1 of algebra 1. It crosses the y-axis. The b value is negative 4. And from that point, I go down 3, 1, 2, 3, over 1. I'm off the graph, right? So because I'm off the graph, I'm going to use that pattern of down 3 over 1. I want to use that pattern backwards, up 1, 2, 3 over 1 this way. Wait, yeah, that's right. Up 1, 2, 3 over 1 this way. Up 1, 2, 3 over 1 this way. So that red equation really is that red line right there. Okay, guys, so we have the line that represents this red equation, but the thing about piecewise functions, we're talking about pieces of those lines. So here's the condition. The condition says if negative 2 is less than or equal to x, which is less than 0. So we only want to show the x values that are between negative 2 and 0. Now, what has helped me in the past is to get like two little Post-its, right? And I'm just going to put like some squares right here instead of Post-its. And I'm going to put these Post-its at the certain x values that they want. The condition says from negative 2 on x. So I'm going to take this one and go to negative 2 on the x, which is right there, and go to 0 with the other Post-it or with the other piece of paper. And this is what we want to show only. From here to here only. We don't want to show any of this. We don't want to show any of that. We do want it to be a solid dot at the x value of negative 2. We do want it to be an open dot at the x value of 0. So I need to erase everything up here and everything down here and just leave that piece. Does that make sense?
Yes.
Okay, so let's do that with your pencil. Go ahead and erase anything that was on the left side of negative 2 and anything that's on the right side of the x value of 0. So the negative 2, that was a endpoint, and I'm going to make it a solid endpoint right there. And the endpoint at 0, it's going to be an open dot endpoint. That's really ugly. Let me white out the inside dot right there. There you go. That's an open dot.
Sorry, was it done?
So now we could move on to the next piece of this piecewise function. I'm going to highlight this part in blue, this piece, and then I'm going to rewrite it. Y equals negative 2x plus 3. Now this rewriting, I only do this for me, right? This helps me graph the lines, and then I could worry about erasing the piece that they don't want me to look at, okay? So you don't technically have to rewrite them the way I do, but it helped me back in high school. Maybe it helps you right now. Okay, so it crosses at 3. That's the b value. The b value is 3. Crosses right there at 3. I go down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1, all the way over here. And going backwards, it would go up here. So we could draw our line.
But condition.
Yeah, but the condition, we're going to have to do some erasing. That's why I say use a pencil with an eraser. The condition reads that your x values have to be greater than or equal to 0. So go to your x-axis, go to 0, and you only want to show the greater than or equal to 0, which is to the right. So if you take like a piece of paper and put it on the x value of 0, that will leave you with what you want to show. In other words, you don't want to show this piece of the blue line. You only want to show this piece. And you want this at the x value of 0, you want it to be a solid dot. So yeah, solid dot, erase this part up here. So that's what we're doing. We're erasing that part up there. And there's your graph. That's your piecewise function right there. Okay. It has two parts to it, two pieces to it. We can now even talk about the domain and the range of this piecewise function. So what would the domain be of this piecewise function?
Negative 2 is less than or equal to 3.
Okay, now,
Or x and then which is less than.
X is less than
3.
No.
Or you do
You
that.
start with the
X is greater than or equal to negative 2.
x is greater than or equal to negative 2. Now, it's this simple, guys.
Oh yeah.
It's either going to the left, which would be x is less than a certain value, or going to the right, which is x is greater than a certain value. And obviously, there's no arrow going to the left. The graph does not exist at the x value of negative 5. It doesn't exist at negative 4. It doesn't exist even at negative 3. Look at no part of that red or blue touches the x value of negative 3. It starts touching right there. It begins at negative 2, and it exists to the right. So x is greater than or equal to negative 2. Are you with me?
Yes.
Good. Okay. So now for the range. The range are your y values. It's up and down. If you see like an arrow going up forever, then and down forever, then you would say all real numbers, right? Y equals all real numbers. But obviously we don't see up and down forever. We see an endpoint way up there and an arrow going down. So what do we say our range is in terms of y?
Y is less than or equal to 3.
There you go. Y is less than or equal to 3. Not bad, huh?
Nope.
That is a piecewise function. Let's look at this crazy piecewise function. Now, the first one we actually graphed. This one's already graphed for us. Let's go backwards and write the actual piecewise function equation. Now notice that we have an area right here. It says write your piecewise function here. We're going to use this whole area. I know it's a lot of space, but this is what we want to start with. Let's give it a name. It's either going to be f of x or g of x or h of x, whatever you want to call it. I want to call it f of x equals, I want to put these big giant brackets like this. Now, why am I putting big giant brackets? Because I could see that there's one piece, two pieces, three pieces. That means I need to write down right here three different equations. One equation, two equations, three equations. Are you with me?
Yes.
All right. So the first equation, and if you're thinking, well, which one do I write first? Do I do this little piece first? Do I do this piece? Let's look at graphs the way we read sentences from left to right. So this first one obviously is a U-shaped curve, and I hope we remember it was on the front side of this worksheet that a U-shaped curve is really a parabola. I want to do this one in blue. Has a solid dot right there, has an arrow up there. So, and even if you forgot about parabolas, which we did kind of cover in second semester Algebra 1, even if you forgot, it says right here, hint, use y equals x squared for the parabola portion. So this first part that we're seeing is the equation y equals x squared. Now, y equals x squared would produce the entire parabola that goes that way forever as well. But we know we're only looking at a piece. So that means we need to give it a condition. Now, instead of me just writing y equals x squared, f of x is the same thing as y. So this is like saying y equals, I'm going to put my x squared right here as the first equation of the three of this piecewise function. Now the condition, I need to write down if what? If your x values are they less than a certain value, or are they greater than a certain value? Less than or equal to 1. That's right. X is less than or equal to 1. Perfect. Thank you guys so much for participating. Now let's move on to the next portion. As we're going from left to right, we see this little segment. Now this little segment really is a piece of a larger infinite line. Okay? Right? So this green segment is really a piece of what I would say is the original line that goes left and right forever. Now, what equation would represent a horizontal line that crosses the y-axis at 3?
Y equals 3.
Y equals 3. So we know that this line's really y equals 3, but then again, we only want the piece of it. That's why I say if you don't have an eraser, you shouldn't be doing any of this. We only have that piece of it, which is really from the x value of 1 to the x value of 2, right? So let's write the second one like this. Instead of f of x equals, instead of y equals, here's y, here's equals, and we're going to put a 3 right here. Put a 3 right there. And of course, if
1 is less than x, which is less than or equal to 2.
That's exactly right. So this right here is the x value of 1. This right here is the x value of 2. And we know that the line's between it. So let's do that. Let's put a 1, let's put a 2, put the x like that in between it, and put less than symbols always. Now, of course, we do have a solid dot. Solid dot is at the x value of 2, so let's put a solid line underneath that, because that'll represent the solid dot at the x value of 2. So we've done the blue piece of the parabola, the green piece of the horizontal line. Now we're going to do, I want to do this one in red. The red piece of this line. Now, we know in Algebra 1 that lines, equations of lines that are in slope-intercept form, you need a m and you need a b. Could somebody tell me the slope of this red line?
1.
Yep, it goes up 1 over 1, so m, you could put 1, you could put 1 over 1, whatever you want. What is the b value? Where would this red line cross? Now remember, we're looking at a piece of it, but the entire thing would go all the way this way.
0.
So it would cross at 0. Now again, the only reason I'm extending it so you could see the b value, and now I'm going to erase it. So that would be
1 plus 0.
the equation y equals 1x plus 0. Or 1 over 1x plus 0. But in reality, 1 over 1 is the same thing as 1. And you know what? You don't really even need the 1, huh? And you don't even need the 0 either, right?
You just need the x.
So this line right here is really just y equals x. So let's actually write that. Y equals, what do I write right here?
Yes.
X, that's right.
If
If
x is
x is
greater than or equal
greater than 2. Dun dun, we're done. Now, if you understand that, you're doing great, okay? Now, if you're like, oh, wait a minute, I kind of understand it, that's still great. You know what? We're gonna spend the whole week on this section, all right? So if you're just kind of getting it, that's great. So let's talk domain and range before we move on, just for funsies here. The domain, does this piecewise function, does it go to the left forever?
Yes.
Yes, it does. Even though it curves up, we know that it still exists at -4, but just way up there off the graph. It exists at -10, just way up there off the graph. So it does go to the left forever, and it does go to the right forever because of the red line going with the arrow going that way forever.
X equals all real numbers.
That's exactly right. X equals all real numbers for the domain. Now the range are your y values. It's no longer left and right. It's now up and down. So do you see any arrows that say that it goes up forever?
No.
No.
There's no arrows that say that it goes
Yeah,
up forever?
both, yeah.
Yeah, okay. And does it say any arrows that go down forever?
No.
No, okay, so you can't say y equals all real numbers for the range because it doesn't go up and down forever. So the question is, where does it start existing and where does it go in terms of y, in terms of up and down? What's your lowest value?
0.
0, and it's going up from 0. So how do we say that? We say y is greater than or equal to 0. There's your domain and your range for that f of x piecewise function. Stay with me, guys. It's a long lesson. Jump into this one right here. So sometimes I'll give you the piecewise function and you need to graph it, and sometimes I give you the graph and you need to write the piecewise function. Okay? So on this one, you could call it whatever you want, f of x, g of x, h of x. I want to call it again f of x. I want to put some brackets, but they don't have to be that huge because I don't need 3 equations on this one. How many equations do I need?
2.
2, that's right. So again, which one do I look at first? Should I look at this one up here or this one down here?
That one down
This one down there. Why? Because from left to right, that's the first one that I see. So that's the one I'm going to work with. So what is this? Let me call it a blue line. Open dot. What is this blue line? You need a slope and you need a y-intercept.
X.
So it's going to be y equals 1 over 1 x plus 0, which is just really y equals x, right? Okay. And yes, it goes this way forever, but we're only looking at the piece from this x value of 0 to the left. Okay. So this says y equals, right? Y equals, and instead of 1 over 1 x plus 0, I'm just going to say y equals x. Condition, if what? X is
Less than or equal to 0.
less than
Oh,
less than 0, right? Why not or equal to? Because that is an open dot right there, so I don't need a solid line underneath that inequality. So we got the red, or not the red, we got the blue line with the blue condition to only show the left part of it, okay? Because normally your line would exist over here as well, but with the condition, it's only showing the left side. Let's move on to the next one. I'm going to do the next one in green. It's a solid dot, and obviously this is a piece of a horizontal line. Normally horizontal lines go to the left forever and to the right forever, but as you can see right here, we're only looking at a certain piece of that horizontal line. But anyways, what is that horizontal line? What equation would that be?
X is greater than or equal to 0.
That's the condition, yes, but how about the equation itself? Y equals 2. Any horizontal line crossing the y-axis is simply y equals the value that it crosses at. Y equals 2 in this case. So I'm going to say y equals 2. Condition, if what? You already said the condition?
If x is greater than or equal to 0.
Greater than or equal to 0. And that's it. Now, the domain and the range are a little bit more interesting on this one. The domain is pretty easy. What's the domain?
The domain is x equals
All real numbers. Why? Because it does go to the left forever. The blue one goes to the left and down. So it goes to the left forever. It goes to the right forever because the green one goes to the right forever. So in terms of your x values, it does go to the left and to the right forever. That's why we say x equals all real numbers. Now in terms of y, in terms of the range, a lot of people say that the inequality that represents the range is y is less than or equal to 2. But that's actually incorrect. Okay? See, if you're saying y is less than or equal to 2, you're telling me that it could be 2, which absolutely, yeah, y could be 2. But you're also saying that it could be 1. And obviously, there is no part of the graph that goes to the y value of 1. So if you're thinking of the y number line, where are these pieces at? Well, for sure it's at 2. So you could write y equals 2. But in addition to that, it could also be, so I put y equals 2, or y could be less than 0. Y could be less than 0. It could be less than 0 for sure, because this blue line is below 0. Or it could be y equals 2. But it can't be any of these values. Moving on to this guy over here. So once again, when they give me a f of x piecewise function, I like to take one piece at a time, and I like to rewrite them. So I'm going to highlight that in red. I'm going to rewrite it in red. Y equals negative 1/2 x minus 2. So how do we graph that red equation? It crosses the y-axis. The b value is negative 2. And from that point, I'm going to go down 1 over 2. Down 1 over 2. And I'm going to put a dot right there. And I'm going to continue to go down 1 over 2. And I'm going to use this pattern backwards to extend it in the other direction. And I'm going to draw an arrow through all those dots, or a line through all those dots. And now we have to represent the condition. The condition is x is less than or equal to negative 2. I wouldn't write it down with the pen because you're going to have to erase, right? Yeah, we're going to have to erase this line. Now check this out. It's saying x is less than or equal to negative 2. So your x value of -2, that would be like getting a paper and going to -2 on the x. Hold on a second, let me arrange this better. Go to -2, which is right there, right? That's the x value of -2. And it's saying less than or equal to -2, so it'd be a solid dot going that way. You don't want to show any of this. So that's why I say we need an eraser. So you only want to show this piece with the solid dot right there. You want to erase everything else. That's what I'm going to do right now. I want to erase everything that's on this side. So that is a solid dot. That's the first piece. Let's move on to the next piece. I want to go with the next piece in blue. It says f of x equals 1. So I'm going to rewrite it right here on the side. Y equals 1. F of x is the same thing as y. Y equals 1 is a horizontal line crossing the y-axis at 1. It does go to the left forever and to the right forever. However, they have a condition. They only want you to show the piece that's between -2 and +1. So that's like taking a piece of paper and, or not, because my iPad's not working right now. It's like taking a piece of paper and putting that piece of paper on the x value of -2 and putting the other piece of paper on the x value of +1 and only showing that blue segment right there. Okay? You only want to show that little tiny blue piece of the line. You don't want to show anything else. So I want to erase this part, erase that part. So you don't want to show any of this piece over here. You don't want to show any of this piece over here. Now, we do have endpoints. Question is, which one is a solid dot and which one's an open dot?
An open dot is -2, 1.
The open dot is at -2, right?
Yeah.
And the other one's solid because it has a solid line underneath the inequality, solid dot. Finally, the last one. The last one, y equals 2x. I'm going to rewrite it right here on the side. Y equals 2x. You could put 2x plus 0. You could put 2 over 1, x plus 0. Bottom line is it does cross at 0. Again, if you have a pen, don't do this, all right? You're going to go up 2 over 1, up 2 over 1. You could use that pattern backwards. Whoops, got a little carried away right there. So here's my green line. Y equals 2x. But that's the line y equals 2x without a condition. I do have a condition. X has to be greater than 1. So where's 1 at and where's greater than 1? That's like taking a piece of paper and putting it on the x value. Why is this not working? I apologize. Putting it on the x value of 1. So that's the only piece that you want to show, because greater than 1 is to the right. You don't want to show anything to the left of the x value of 1. So I need to erase everything over here, put a solid open dot right there because it's not a solid line underneath the inequality. So that's what I'm going to do. I want to erase all of this and put an open dot right there at the end point, the coordinate 1, 2. There's my graph. It's time for some domain and range. The domain is x equals, anybody? All real numbers, because it goes to the left and it goes to the right forever. Obviously, the red part shows you that it goes to the left forever. The green part shows you that it goes to the right forever. So all real numbers on x. There are no gaps. There are no missing values. And time for range, that one's pretty easy as well. What is range? Is it y equals all real numbers?
No.
No?
It's negative is y is greater than or equal to -1.
Y is greater than or equal to -1 is absolutely right. We know that none of this graph exists at -5 on the y. It doesn't exist at -3. It starts existing right here at the y value of -1, and it clearly is above with no gaps. Okay, so there's your piecewise function with the domain and the range. This last one right here, okay? Again, I highly recommend for you to rewrite your equations. I want to take a look at this first equation. I want to do it in red. I want to rewrite it right here in red. Y equals 3 over 2x. There is no b. You can put a plus 0 if you want. So how do we graph that? It crosses at 0. You go up 1, 2, 3 over 2. And if you want, continue to go up 3, 1, 2, 3 over 2. You'll be over here off the graph. And let's go backwards. Down 1, 2, 3 over 2. You'll be right there. And you could continue down 1, 2, 3 over 2 in that opposite direction. You'll be down here. So here is your infinite red line. Whoops, a little crooked, but that's your infinite red line to the equation y equals 3/2 x plus 0. However, we know that it has a condition. The condition is you only want to show x being less than or equal to -2. Less than is to the left. Greater than is to the right. So you only want to show to the left of the x value of -2. So if I take this and go to the x value of -2, there it is. That's the x value of -2. At -3, here's -2. If I put my paper right there, I'll only see the left side. I want to erase everything else. So let's erase everything else. And that is a solid dot at -2 on the x. Now let's move on to the next one. I'm going to do the next one in blue. Y equals, I know it says g of x, but that really is the same thing as y. Y equals x plus 1. I'm going to rewrite it down here. Y equals x plus 1. How do I graph that? That crosses at 1. From that point 1, I go up 1 over 1, up 1 over 1. And I go as far as I want, up 1 over 1. And I would use that same pattern backwards to extend it in the other direction. And that really is the infinite line that goes in both directions, y equals x plus 1. However, we do have this condition. You only want to show your x values, or the piece of this graph that have your x values between -2 and 1. So that's like taking a piece of paper, going to -2 on the x-axis, which is right there. There's -2 on the x-axis. Taking another piece of paper, going to +1 on the x-axis, right there. And that blue diagonal segment is all you want to show. So you have to erase everything over here and everything up there. It's going to be an open dot right here at -2, and it's going to be a solid dot at +1. So let's start erasing. It's going to be an open dot at -2 and a solid dot at +1. Open dot here, solid dot there. And then last but not least, we're going to jump to y equals 4. Do this one in green. Y equals 4. We should all know that y equals 4 is a horizontal line crossing the y-axis at 4, going both to the left and to the right forever. But the condition is that they only want you to show the x values between 1 and 3. So if you get a piece of paper, go to the x value of 1. It's right there. Get a piece of paper, go to the x value of 3, right there. That's the only piece of the green line that you want to show. And yes, they're both going to be open dots because neither of the inequalities have solid lines underneath them. So let's erase anything that's on the outside of 1 and 3 on the x. And we said both of them are going to be open dots. So that little green line segment has to have 2 open dots. One right here, one over there. And we are done. One other thing, that this one is the range on this guy is crazy. The domain's pretty simple. The domain is that this entire graph, in terms of x values, is at 3, but to the left. So we'd say x is less than 3, right? The green one's up there, blue one, the red one, everything is at x is less than 3. So the domain, x is less than 3. Now the range is crazy. The range is crazy because there are several gaps, there are several holes when we're talking about the y number line. You see, if I asked you, Could this entire piecewise function, does it exist down here in the negative 10, negative 20?
Yeah.
Yes, it does. The red one keeps going down forever. Does it exist at negative 5? Yes. Does it exist at negative 4? Negative 3? Negative 2? No. In terms of y, it doesn't exist at negative 2. And then it starts existing again from negative 1 all the way up to positive 2. But then it stops existing, and then it exists again at 4. Does that make sense? Kind of weird, right? So let's tackle this one piece at a time. This top part is at the y value of 4. So for sure, the range is y equals 4. That's one value that the range could be. Or it could be the blue one next, which is really the y values from negative 1 all the way up to positive 2. So from negative 1 all the way up to positive 2 with the y value in between them with the less than symbols. You always put your smaller number on the left, the bigger number on the right. And since it's a solid dot at the y value of 2, we're going to put a solid line underneath the inequality where the 2 is at. And last but not least, let's deal with the red portion of this, which is simply the y value of negative 3, solid dot below. So we'd say, or you could say y is less than or equal to negative 3. Maybe I should have stayed color coordinated. I hope that makes sense. That's a crazy looking range. The domain was simple, but that's what piecewise functions are all about, ladies and gentlemen. Fun stuff.